Welcome back to Aeromotive, and welcome back to our instructional videos. In this segment, we're going to show you how to cut, strip, and splice. Some of the things that we have to consider is the tooling. And let's keep this in mind. We're talking about repairing wire damage in the field. This isn't a benchtop repair. If you want a benchtop repair, I suggest having the wire harness assembly reprocessed. But let's look at some of the tooling that you would use in the field. We have a pair of cutters, precision type, very accurate, and cut up to about 16 gauge strand of wire. We have strippers. I really like these, and I would highly recommend them. The reason I like them is because it cuts the insulation 360 degrees, and it also gives you the wire gauge size, so you know what type of wire you're working with. In addition, when you do strip, be careful not to nick any of the wires as you're pulling back the insulation. We also have a pair of crimpers. These are nice. We recommend these for using some of the splices that we'll demonstrate here today, and they're also good for crimping terminals. And then finally, a heat source. We're going to use this to heat shrink some of the tubing down. So let's get started. In this application, I have two types of splices here. I have a factory or OEM splice, and I have what I'd like to call an aftermarket splice or a mini splice. And you can see from these two, just looking at the barrels, the difference in the splices. In this particular splice, which is a factory, comes with a lot of their connector housings. It's a one piece, which means there's a barrel inside the shrinkable tubing and requires a scissor crimp to make the crimp or crush the barrel. Well, the moment you hear scissor crimp, you should start worrying. Anything with scissors in it, you know you're going to end up cutting something. And usually you end up cutting the shrinkable tubing, which then when you shrink it down, expands and opens up the tubing to moisture, which defeats the purpose. We're going to recommend using this type of splice. It's a two-piece. It comes with a barrel and it comes with shrinkable tubing. So I'm going to start by crimping or creating a splice using this type of insulator. First, we want to grab our wire. In this case, it's about a 20 to 22 gauge. I'm going to use the strippers, and I'm going to find my wire gauge on the tool, and it's illustrated 20, 16, 12, 10. I'll find my hole. I'll cut it back about 1/4 of an inch or less and strip off the insulation. You always want to do an inspection because, as I mentioned, you want to make sure that none of the strands are nicked or cut, because there are limitations to the amount of strands you can have damaged in a wire. So I've stripped one end. I'm going to go back. I'm going to do my other end. Again, going back to the 20 to 18 gauge hole, strip it back. Notice the automatic feature, and it gets the insulation right out of your way. And then now I'm going to come back with the barrel. Really tiny, but look how nice these are. You slide it over the wire, and there's a small inspection hole here. I don't know if you can see that, but that inspection hole is to make sure that you have proper engagement or proper wire depth into the barrel. Unlike this type of splice, you can't tell how deeply you go into the barrel. So when you go to crimp, you don't know if you have enough engagement, or maybe it's too long. But this is a really nice looking splice right here. Next, I'm going to use our crimper. These have a dimple in it, so when you place the splice into your crimper, it's going to create a tiny dimple into the barrel. And then when you release it, snug as a bug in a rug. That's nice. Look at that. That is looking really good. And what's really nice about this too, look at the diameter of the barrel. It's almost the same size as the wire. That's ideal. You can put several splices into a harness assembly when they start looking like that. Now I'm going to slide over our shrinkable tubing. If you notice, one end is colored red, the other is clear. No particular reason for that outside of the fact that it does help designate the size of the barrel. So I'm going to slide this over, And now I'm going to take the other end of my wire and I'm also going to slide it into the barrel, again using my inspection hole to make sure they have proper engagement, which I do. I'm going to take my crimper and I'm going to place a dimple in it. Very nice. Look at that. Little tuck test. That's not going anywhere. Now I'm going to slide the tubing over and I'm going to apply some heat to the shrinkable tubing. I'm going to use this butane torch, which has a heating element at the end that's designed to blow warm air, not an open flame. I'm going to start passing it over the tubing and allow it to start heating up. I like to start in the middle and work my way out. This will help squeeze some of the air out of the splice. And be patient here. Don't feel like you have to rush through this process. It does take a while, but when you are finished, the result is really nice. And it's all about the quality. Right? We want to make sure that this splice lasts as long as the vehicle does. As I begin to heat it up and squeeze the air out of the splice, I'm working my way towards the ends, and the ends have a sealer in it. That's what's really going to protect it from the moisture. Outside of the fact that this shrinkable tubing becomes a very tight fit and actually helps hold the wire intact as well, it'll also seal the ends to keep that moisture out. So I'm going to work my way back and forth now on each end, squeezing that air out, working the insulation. And you'll know when you're finished because you'll start seeing some of the sealer oozing its way out of the end. There we go. That's looking really good. Turn off my torch, and away we go. Look at that. That is nice. You can see the sealant, how it oozed its way out of the tube, and this is ready to go. I just showed you how to use the aftermarket mini splice. Now let me show you the OEM's version. Again, this is one piece. So I'm going to take my wire lead and I'm going to slide it down into the barrel. Again, I can't tell you what's happening inside there. I just can't see it. So I don't know if I'm getting a good contact. I don't want to use a scissor crimp because I know what's going to happen. It's going to end up cutting the insulation or the shrinkable tubing. So I'm going to use my bead crimper. And I'm going to crush the barrel. And I'm going to crush it in two places because, again, I don't know what type of engagement I have inside the barrel. Little tug test. Oop, look at that. Fell right out. So again, you can see the difficulty in using this type of splice. I'm going to try it again. The barrel still looks intact. I'll slide it in one more time. There we go. And do a double take on this one. Again, look at it, the effort I have to use. And then a quick tug test. Looks good. Now let's apply some heat and let's start shrinking this down. Again, I'm starting on the inside, working my way out. The polymer on this type of splice isn't as soft as the mini splices I showed you earlier. It is pretty rigid. The shrink rate isn't as good either. Some shrink rates are 4:1, 3:1, 2:1. This particular type, it looks like it's about a 4:1, which is really good. That's what you want. This way it can be used on a variety of wire gauges. Again, looking for that sealer to get to the ends. You can see it kind of flowing. And on this particular side, you can see how it's already darkened. That's the sealer. I'm going to shrink that down like a rotisserie. I feel like I'm baking a ham. Keep working our way towards the ends, looking for that sealer, getting all the bubbles out of it. And there we go. There's a little bit showing on that end. I'll come back up. One thing to keep in mind too, this type of plastic does not have very good memory. So in other words, you heat it up, and once you're done, it's finished. It will remember where it left off, so you won't have the opportunity to really shrink it back down again. And there we go. Turn off our heat source, and this is your factory splice. This is your mini splice. Look at the difference in diameters. Much cleaner. So we would definitely recommend the use of the mini splice. I'd like to show you two other forms of splices that are out there. The one, again, a mechanical type of splice. It uses this copper or brass colored terminal. And essentially you would lay this brass colored terminal into the wire and use, again, a crimping tool such as this handheld one to roll the terminal and secure it. And then you would take your wire and come on the other end and create your butt splice. Now these are nice, they're very secure, but they do require some special tooling. The materials or metals in this type of splice are really hard, so you would require a special tool to crimp that. In addition, you would have to provide shrinkable tubing, again, to weatherproof the splice. Finally, there's always good old solder. Solder's been around a long time, has a lot of uses, but it is definitely fading out. Solder can be used, again, it worked just as long as some of these others. However, you're applying a lot of heat in a very small area, and in a lot of cases, the insulation actually starts to heat as well. So, not very advantageous to use solder. And it makes the wire very brittle. So that solder joint, over time, as the harness begins to vibrate, also begins to work at that solder joint and snap. There goes your splice. So, in a pinch, consider using solder. But whenever you have the opportunity, think mini splice.